Okay, till the last session, we had completed with first part of organic chemistry, which is nomenclature. So once we understand the naming of organic compounds, now we'll move on to understanding the organic reactions. And to understand the organic reactions and how they actually take place, we will start with the understanding of fundamental concepts in organic reaction. As the name says, it will cover all the fundamental concepts which will be required to understand the organic reactions and how they work, which is the reaction mechanism. The working of a reaction in detail and the step-by-step explanation of a reaction is called mechanism or reaction mechanism. So let's start with the basic word, that is reaction. A reaction can be simply defined as conversion of reactants into the products. Let's say there are two reactants, R1 and R2, and they react together to form the products. In case of organic reaction, the reactant, which contains the carbon and has the functional group which is getting converted into another functional group, that particular organic reactant is called as the substrate. So now onwards, in organic reactions, the carbon containing compound having a functional group, which is a part of the reaction and called as the organic reactant, would be called as substrate. Would be called as substrate. And the other reactant, which is reacting with it, would be called as reagent. So instead of two reactants, we would say there is a reaction between substrate and a reagent. Now, they both react together to form something in between the reactant and the product. So then substance formed in between is called as the intermediate. And this intermediate would be finally converted into the product of the reaction. So basically, I say that every reaction goes through a simple sequence of R, I, P. Of course, not rest in peace, but reactant to intermediate to the products. Now, the whole understanding of the organic reaction lies in the understanding of the intermediate. And to understand the intermediates, we start with the first fundamental concept of organic reaction, that is bond fission. Bond fission. Now, as you all aware, fission refers to the breakdown. You must have heard about nuclear fission that relates to the breaking of a bigger nuclei into smaller nuclei. The fission refers to the breakdown, or it is also called cleavage. Breakdown or cleavage or lysis. So whether you say breakdown, cleavage, lysis, or fission, it all refers to the same thing. Now, we know that organic compounds are consisting of covalent bonds. So I'll specifically say this is related with covalent bond fission. Hence, the bond fission over here would be defined as breakdown of a covalent bond. Now, a covalent bond is formed by sharing of electrons. So let's say there are two atoms which are similar and they share the electrons to form a covalent bond. Now, since the atoms are similar, their electronegativity will also be same. It means that both the electrons will be equally attracted with both the atoms, due to which they will be having equal sharing of electrons. Such type of covalent bonds are referred as non-polar covalent bonds. So in such a case, if the bond breaks down, even the breakdown is going to be symmetrical. Symmetrical breakdown indicates that both the atoms will take one electron each and break to give A dot and A dot, meaning each atom will have one unpaired electron. Now, this representation is called as the fish hook arrow. Fishhook arrow is also called as the half-headed arrow, which indicates the equal distribution of electrons to the respective atoms. So this symmetrical breakdown of a covalent bond resulting into the atoms taking one unpaired electron is referred as free radicals. The A dot and A dot are referred as free radicals because radicals refers to the unshared valency. Now coming to the name, such type of lysis, meaning the symmetrical breakdown of a covalent bond, is called as homolytic cleavage or simply homolysis. So on the other hand, if I take two atoms which are different, let's say I have A and B. Again, they share the electrons to form a covalent bond. But now the atoms are dissimilar, so they will have difference in electronegativity. So assuming that electronegativity of B is greater than electronegativity of A, it means that B will have more attraction of electron towards itself, due to which the electron density around B will increase and around A will decrease. Thereby, B will acquire a partial negative charge and A will acquire a partial positive charge, making the covalent bond a polar covalent bond. Now, this particular transfer of electron is shown by complete arrow. So, complete arrow indicates the shift of the electron towards a more electronegative atom. Now, when such type of polar covalent bond breaks, then B will take both the shared electrons towards itself and break down to form a negatively charged ion, that is anion, and A will be without any electrons acquiring a positive charge, forming a cation. So cations are basically now onwards the ions which are deficient of electron. So organic में cations would be now on referred as electron deficient, or I say garib. Cations are garib, electron deficient, and anions would be referred as electron sufficient or electron rich या अमीर. So इसी अमीर गरीब की कहानी we have to understand for the organic reactions का mechanism understanding. Now coming to the name, such type of unsymmetrical breakdown of a covalent bond is called as heterolytic cleavage or heterolysis. So bond fission could be classified into two parts, homolysis and heterolysis. Now let's convert this concept into the organic concept. So the focus for organic reactions will be on carbon. So if I say that there is a covalent bond formed between the carbon atoms, then such type of single bond is formed between the carbon atoms in an alkane, and I take the simplest example of ethane. So I can relate this as a symmetrical breakdown of a covalent bond indicated by a fishhook arrow, where each atom will take away the electron to form CH3 dot and CH3 dot. Now the CH3 is called a methyl group and the dot refers to the free radicals. Hence, ethane ka homolysis refers to the formation of methyl free radicals. Now similarly, it can form the ethyl free radicals, isopropyl free radicals, third butyl free radicals. In general, the carbon free radicals indicated as carbon with a dot. Now case 2. Let's say I have a covalent bond between different atoms. Example, methyl chloride. So here the covalent bond is formed between carbon and chlorine, wherein the electronegativity of chlorine is more than electronegativity of carbon. In that case, the electron shift will be towards chlorine, where chlorine acquires delta minus, carbon acquires delta plus. So we understand that this will be the heterolytic cleavage or heterolysis, wherein the carbon will acquire a complete positive charge and chlorine will have the shared electron, which is called as the lone pair with a negative charge. Now, with respect to carbon having a positive charge, it's called carbon cation. Shortly, we call it as carbocation. We call it as carbocation, or the cation has the name ending with yum, hence we also call it as carbonium. Now we can also have a case wherein there is a covalent bond between carbon and an atom which is less electronegative than carbon. So consider the example of this, which is acetaldehyde, and focus on the bond between hydrogen and carbon. Now we know that the single bond carbon has an electronegativity 2.5 and the hydrogen has the electronegativity 2.1. So of course, the electronegativity of carbon here is greater than H. Thereby, the shift will be towards carbon, carbon acquiring delta minus, hydrogen acquiring delta plus. Again, the bond would be broken down electrolytically, giving you H with a plus, carbon with the lone pair and a negative charge, followed by CH2CHO. So here we get a carbon with a negative charge, which is called carbon ka anion, also called carbanion. So with these three cases, we understand that in any organic reaction, the bond fission, whether it is homolysis or heterolysis, results in the formation of free radicals or the carbocation, carbonium ion, or the carbon anion, that is carbon ion. So these are simply the intermediates of the organic reaction, which we were talking about, the RIP ka I. So organic reaction have three intermediates. First, carbon free radicals. Second, carbocation. Third, carb anion. Also, the information with regards to the carbocation you should remember is it is sp2 hybridized. And we know that sp2 has a shape of planar with an angle of 120 degree. And the carbanion is sp3, which has a shape of tetrahedral, but because of the lone pair, it is distorted. The shape is distorted, and the distorted tetrahedral is like carbon having three bonds appearing or taking the shape of pyramid. Hence, it is referred as pyramidal. sp3 distorted tetrahedral or pyramidal. The information about the hybridization and the shape needs to be remembered. So that is the introduction to the covalent bond fission, with a conclusion that the fission could take place in two ways, homo and heterolysis, resulting in radicals or the carbocation or the carbanion, which are the intermediates. Now, with regards to this intermediates, further, we need to have an understanding of types of carbocation and their relative stability. वैसे तो सारे ही intermediates are highly reactive and unstable, but among them, the relative stability is very important, the application of which we will understand in the later part. So now, for carbocation, if I say there is CH3 with a plus, I can call it as methyl ka carbocation or simply methyl cation. Then CH3CH2 with a plus would refer to ethyl group and ethyl cation. Then I have CH3, CH3, which is isopropyl group with a plus called as isopropyl cation. And I can have CH3C, CH3, CH3, which is tert butyl with a plus and hence called tert butyl cation. Now, among these cations, further observation, the ethyl group has a CH2 carbon attached to only one carbon. So such type of carbon which is attached to only one carbon is referred as a primary carbon. So this is primary carbocation. This carbon is attached to two carbons, hence secondary, and this carbon is attached to three, hence it is tertiary. You can clearly observe that CH2 carbon is attached to 1 methyl, CH plus is attached to 2 methyl, C plus is attached to 3 methyl groups. And the methyl is the simplest nanna sa chota sa cation out of them. So the types of carbocation are methyl, primary, secondary, and tertiary. That is the first answer. Now, among the carbocations, as of now, you need to remember that the alkyl groups like methyl, ethyl, propyl attached to the carbocation stabilize them. Alkyl group stabilizes the carbocation. So with this statement being kept in mind, more the alkyl groups, more will be the stability. So with regards to that, the tertiary, which is having 3 alkyl groups attached to the C plus, would be the most stable carbocation. Hence, the order would be tertiary, more stable than secondary, more stable than primary, and the simplest of them, which is also the most unstable, is methyl cation. Now, this particular order of stability is same for the carbon free radicals. Why? We'll understand later when we explore the concept of inductive effect and hyperconjugation. So that will be discussed in the later part of fundamental concepts. But remember, if I replace the positive charge with a dot, then the same order is valid even for the carbon-free radicals. Likewise, the third intermediate which we talked about was carb anion. So we also have the types of carb anion and their stability to be compared. So for the carbon ion, I will now just replace the plus charge by a minus charge. Plus by a minus charge. So I will get a methyl carbon ion or methyl anion. Then I'll have ethyl anion, isopropyl anion, third butyl anion. So the types of the intermediate, whether it is carbon, free radical, carbocation, and carbanion, remains the same, which is methyl, primary, secondary, and tertiary. Now, if I reverse these statements for the carbanion, then simply the alkyl groups attached to the carbanion have a tendency to destabilize the carbanion. Destabilize the carbanion. So more the alkyl groups attached to the carbanion, more will be the instability. And that is why in this case, the tertiary becomes the least stable, methyl becomes the most stable. So order of stability is in the decreasing order now, methyl, primary, secondary, and tertiary. So that is the relative comparison of the stability of the intermediates for the organic reactions. So to sum up, this was the part about the first fundamental concept important to understand the bond fission and their intermediates. Also to add, the homolysis or the heterolysis takes place under some important conditions. In case of homolysis, it takes place in the presence of UV light or diffused sunlight or high temperature, non-polar solvent, or in the presence of peroxide. Now let's understand these conditions. If you look at the first three conditions, UV light, diffuse sunlight, or high temperature, all refers to providing more energy to the reaction. And that energy could be provided naturally through the UV light or sunlight, or by heating simply by increasing the temperature. Since the homolysis is related with non-polar compounds, they can be broken with the help of non-polar solvents. And peroxides, being a symmetrical structure, also helps in symmetrical fission. And that is why this is also the example of homolysis condition. Heterolysis only has one important condition, and that is in the presence of polar solvent. And the universal polar solvent we all know is water. So water breaks down the polar covalent compounds into ions. And you can relate this with the famous example of HCl, which is a covalent compound, but in water, when dissolved in water, it breaks down into H plus and Cl minus, which is in aqueous solution. So that is the simplest example with regards to heterolysis. Okay. Now, after considering the fundamental concepts of bond fission, we now move to the starting part where I introduced that the two reactants in organic reaction are referred as substrate and the reagent. So generally, the reactant involving the carbon atom is called as a substrate. For example, if I have an alkene ethene added with bromine Br2, then the addition reaction takes place with both the bromine atom adding across the double bond, converting it into single bond. So the carbon wala reactant is called as the substrate, and the other reactant is called as the reagent, and the final thing is called as a product. Again, for example, if I have a benzene reacting with methyl chloride, then the methyl group attaches to the benzene, giving you toluene compound along with HCl. And this H of the benzene goes away and forms the HCl. Now, the main carbon reactant, which is formed with regards to the product, is or would be referred as the substrate, and the one responsible for conversion would be referred as the reagent. So the main carbon containing compound would be the product, and the HCl would be the byproduct of the reaction. So that's how you classify the substrate and the reagent. Now, substrates are generally the carbon compounds. The reagent could be either carbon compounds or non-carbon compounds. So to understand them, we'll talk about the reagents, which are classified into two types. One, which is electron deficient reagent, and other, which is electron rich reagent. So in the previous part itself, I said that electron deficient is something which is a cation or garib. Electron rich is something which is referred as anion or amide. Now, the one which is electron deficient, the reagent, is referred as electron loving reagents because they will have the love for the electrons to become stable. Hence, the electron loving reagents are called electrophilic reagents, or they are shortly called as electrophile. And electron rich would have the hate for electrons, so you can call it as electrophobic reagents. But the opposite of that would be nucleus loving. Hence, they are referred as nucleophilic reagents. Nucleophilic reagents, or shortly referred as a nucleophile. So reagents in organic chemistry are referred or divided into two categories. One is Garib reagent, other is amide reagent. Garib is electrophilic reagent because it's electron deficient, hence electron loving, and the amide is electron rich or electron hating or nucleus loving reagents, hence we call it as nucleophilic reagents. And also some alternate information you need to remember. The electrophilic and the nucleophilic reagents are also defined with the Lewis theory, which we will be discussing in the acid-base theory of ionic equilibrium chapter. But as of now, you can remember that the electrophilic reagents are called as Lewis acids and the nucleophilic reagents are called as the Lewis base. Reason being, the electron-rich reagents would have a tendency to donate a lone pair, and according to Lewis, the lone pair donors are Lewis bases. And जो करीब होते हैं वो lone pair accept करने की कोशिश करेंगे, so they are lone pair acceptors and hence referred as Lewis acids. Now, under electrophilic reagents, what would be the examples? The examples would be incomplete octet molecules. Incomplete octet molecules. Of course, the species whose octet is not complete would also always be in search of electrons and they will be electron deficient or the electrophiles. And on the other end here, the species which have their octet complete but with extra pair of electrons which are unshared, meaning with the lone pairs, would be classified into nucleophilic reagents or nucleophiles. So example, incomplete octet mein we have boron trifluoride BF3, aluminium trichloride AlCl3. The boron and aluminium atom both forms 3 bonds, meaning equal to 6 electrons. So they have sextet of electrons and they are electron deficient. On the other hand, the first example of the nucleophiles would be the molecules like ammonia or the water, in which the oxygen or nitrogen have the complete octet, but they have extra electrons which are not shared, called the lone pairs. So they would be behaving as nucleophiles in the organic reactions. Secondly, as I said, the Garib species are the cations. So all the cations you will come across will be electrophiles and all the anions which you will come across would be anions. So cations के तो बहुत सारे examples हैं. We can have the examples of methyl cation. In fact, all the cations which we discussed, methyl, ethyl, isopropyl, tert butyl, and so on. Also, the functional group like carbonyl or the ketonyl, in which the carbon is electron deficient, having a positive charge, could be attacked by the electron-rich reagent, that is a nucleophile. So, even the carbonyl would be considered as the electrophile. And cations में और बहुत सारे examples आ सकते हैं, जैसे I can have CH3 C double bond O with the carbon having a plus, that is electron deficient. Or I can have a chloronium ion Cl plus, nitronium ion NO2 plus, sulfonium ion SO3H plus. So what you need to understand is any positively charged species having a plus charge would all be referred as the electrophiles. Under the anions, we have many examples like Cl minus or all the halides, NH2 minus, that is the amide anion, or the alkoxide C2H5O negative, HS negative, which is bisulfide, or I can have the H negative, which is hydride. All these species with a negative charge will be now onwards referred as nucleophiles. So this is how you should understand the electrophile and the nucleophile in the compounds. Now there could be questions like identify the electrophilic center in the compounds given. Let's say I have acetaldehyde which is given. So as I discussed, in acetaldehyde, you have double bond between carbon oxygen, where oxygen acquires minus and carbon plus. So this will be the electrophilic center. Similarly, in methyl cyanide, nitrogen being more electronegative gets minus and carbon gets plus. This is the electrophilic center. In methyl iodide, iodine being more electronegative gets minus, carbon plus. So this is the electrophilic center. So this is how the questions would come with regards to reagents. We just need to identify the electrophile and the nucleophile. Now some important properties. If there is electrophilic reagent, it will be attacked by a nucleophile. So of course, Garib will be asking the electrons from Amir. But if there is a nucleophile, then it will donate the electrons to the Garib electrophile. So basically, nucleophile is going to transfer its lone pair or electron pair to the electrophile. So the transfer will always be from the donor nucleophile to the acceptor electrophile. So it's just different way of naming them for the organic reactions. So this is the second concept with respect to substrate and the reagent. Now moving to the third concept, that is electronic movements taking place in the organic reaction. Simply electron का movement कैसे होता है, that concept we will understand in the topic of electronic movements. Let's take some examples. If I have a double bond Y, and if there is the transfer of the weaker pi electrons to the adjacent bond position, then the movement is shown from the double to the position to which it is shifted. And because of that, now the double will change to single, single will change to double. But if the pi bond or the pi electron is shifted to the adjacent atom, not to a bond like this, then now the pi electrons would appear on the Y as a lone pair instead of the other side single changing to a double. Similarly, if Y already has a lone pair and if it donates to the adjacent bond position, then the single on the right would change to a double. So this is how the electron ka movements would be understood in the organic reactions. Let's also understand with a simple organic reaction of HO negative reacting with the methyl bromide. If you relate, it's a very simple reaction of the bromide getting substituted by OH to methyl alcohol and the bromide getting eliminated as Br minus. So now, if we talk about the substrate and the reagent concept, of course, the carbon containing compound would be called as a substrate. This would be a reagent. Now, to be more specific, this reagent with a negative charge is called a nucleophilic reagent. And as we discussed, the nucleophile would attack the electron deficient center. And in case of methyl bromide, bromine being more electronegative has minus and carbon has a plus. So this amine will donate its electron to the Garib carbon and will kick out the Br. Look at the electron movements. Negative donates to the carbon. This bond breaks and the Br is eliminated from the reaction, converting the methyl bromide to methyl alcohol, which is, of course, the product of the reaction. And the Br minus is the leaving group of the reaction, the byproduct, or simply a more sophisticated word, that is leaving group. Similarly, if I have a methyl chloride, assuming this bond breaks homolytically due to some special condition, then in such case, a symmetrical bond fission would be indicated by the fish hook arrow, and this fish hook arrow would generate the free radicals as methyl free radical and a chlorine free radical. Of course, this can be done with the help of UV light, diffuse sunlight, non-polar solvent, peroxide, or by just heating, supplying high temperature. So that is a simple fundamental concept related to the electron ka movements for organic reactions. After understanding the electron ka movements, we understand the electron ka displacement. The displacement, or simply again the movement of electron, but now taking place in a single covalent bond. The topic is in covalent bond, but more specifically in a single covalent bond. Now, to understand this, let's take an example of a chain of carbon atoms which is bonded to an electronegative element like chlorine. Satisfy the valency, I have H3, H2, H2, and H2. Now, if I focus on the last bond, which is between the carbon and chlorine, we know that this is a polar covalent bond with chlorine attracting the shared electron towards itself, giving you a partial negative charge, and the CH2 carbon acquiring a partial positive charge, hence making the covalent bond to become polar. Now, this carbon, already having a positive charge, will try to attract the shared electrons from the adjacent carbon, due to which the adjacent carbon will acquire a lower partial positive charge indicated by double delta, मतलब छोटा सा charge. This in turn will attract the electron from the adjacent carbon, developing a further smaller charge of triple delta, and it will extend to the fourth carbon, giving you 4 delta with a plus, indicating a very chota sa charge. So this concept is analogous to the tug of war. So let's say this particular bond between the carbon and chlorine is the rope, and the tug of war is played by two teams in which one team has only the chlorine atom and the other has 4 carbon atoms. So of course, chlorine being more electronegative has more power to attract the electrons, due to which the rope would be more shifted towards the chlorine atom, and the highest effect will be to the person who is holding the rope. The person who is at the last would have the least effect of the attraction by the chlorine atom, and that is what is indicated by chota sa positive charge on the carbon atom. So this is the inductive effect. Why we call it as inductive? Because inductive का मतलब होता है passing on. So the charge is passed on, or the effect is passed on from one atom to another. So this carbon is passing to the second carbon, second to the third, third to the fourth. This passing on wala effect is called inducing effect or inductive effect. So understand the important points. First, the inductive effect ka condition. Why would it take place? So it will take place whenever there is a difference in electronegativity, due to which a partial polarization is developed between the atom. Partial का मतलब होता है delta वाला charge. So partial polarization between the atoms would take place, and this effect is going to remain permanent. Why? Because HCl में भी जो polarity develop होता है due to electron negativity का difference, it's going to be permanent. So it's a permanent but partial polarization. And since you see the fourth carbon has such a small positive charge that at some point of time it will just decrease to zero. So inductive effect is basically valid till a chain of 4 carbon atoms, not more than that, till 4 carbon atoms. So difference in electronegativity would always give you the inductive effect with a partial polarization, effect being permanent, valid till a chain of 4 carbon atoms. So this is how the bond polarization affects the shifting of the charge from one atom to another. Now, inductive effect could be categorized into two types. So let's understand this again. So I have carbon which was bonded to the chlorine atom. The electron was attracted towards the chlorine atom. तो अगर क्लोरीन के नजरिए से देखें तो क्लोरीन क्या कर रहा है, इलेक्ट्रॉन्स को अपनी तरफ खींच रहा है. सो ऐसा अपनी तरफ खींचने वाला ग्रुप या एटम इज कॉल्ड इलेक्ट्रॉन विदड्रॉइंग. विदड्रॉ मतलब खींचना, इलेक्ट्रॉन विदड्रॉइंग ग्रुप. और शॉर्ट में आज के बाद वी विल कॉल देम एज EWG, इलेक्ट्रॉन विदड्रॉइंग ग्रुप्स एज EWG. एंड कार्बन के नजरिए से आप देखोगे तो कार्बन तो बेचारा इलेक्ट्रॉन डोनेट कर रहा है, ठीक है ना. यहाँ देखो कार्बन, ऑल द कार्बन्स आर donating or giving away the electrons to the chlorine because they are weaker as compared to chlorine in terms of electronegativity. That's why the carbon chain entirely, which is an alkyl group, would be called as electron donating group. And this electron donating group in turn is called EDG. Electron donating would be called EDG. So donating मतलब अच्छा इफेक्ट, और विदड्रॉ करना, खींचना, लूटना is बुरा इफेक्ट. So we categorize these two effects into a positive inductive effect, shortly plus I, and बुरा मतलब negative, that is minus I effect. तो प्लस आई में क्या क्या आते हैं? मेटल्स, we know that they have the tendency to donate electrons, तो इलेक्ट्रॉन डोनेटिंग हो जाते हैं. अनाइंस जो कि रिच होते हैं, तो वो भी तो इलेक्ट्रॉन डोनेट्स कर सकते हैं. एंड जो कार्बन का चेन है, जिसको हम अल्काइल ग्रुप बोल सकते हैं, दे आर ऑल्सो द इलेक्ट्रॉन डोनेटिंग ग्रुप्स. So in short, these three examples of metals, anions, alkyl groups. From now on, you will just remember as Ma. Ma is also caring, Ma is also donating. With respect to that, you can remember Ma as the mnemonic for electron donating group, which is EDG, which is plus I, which is Acha effect, which is metals, anions, and alkyl groups. Now, just reverse it. The negative effect related to the minus I would be for the non-metals, which we know have a tendency to accept or gain or withdraw electrons. Cations जो गरीब होंगे वो भी तो इलेक्ट्रॉन लूटेंगे, इलेक्ट्रॉन विड्रॉ करेंगे. एंड अल्काइल के साथ लगा होता है फंक्शनल ग्रुप्स, जिनमें हेटेरो एटम्स होने की वजह से they all have the tendency to withdraw the electrons. So once you remember Ma as plus I, opposite of that you can remember as minus I. So categorizing the plus I and minus I shouldn't be a problem. It's simple. So that completes the inductive effect ka concept with the types of inductive effect discussed in detail. Thanks.